Hi, welcome this week. We're going to speak to Joseph about his current paper on these massive sharks. So I'm just going to ask you, Joseph, thanks again for being here. Could you just tell us about the paper?
Yeah, so the paper was published last week in the open access journal PLOS One, so it's available to pretty much anyone who wants to download it. And the main take-home message from this paper is that we found a very, very large shark that lived during the early Cretaceous, about 100 million years ago. And this shark was quite a bit larger than we thought any of the large free-swimming predatory sharks were at the time. So this animal would have been somewhere on the order of about 20.5 feet long, or about 6.3 meters. And the interesting thing about this specimen is that there's actually another vertebra that was found in Kansas that matches very nicely with it. So we actually think that they're members of the same species. And that vertebra is somewhere on the order of 8.3 meters, or about 27 feet. So this is an animal that would have grown larger than the largest great white shark that we've ever discovered, and quite possibly even bigger than that. So this pushes back the evolution of giant predatory sharks all the way into the early Cretaceous, when we weren't actually sure that they were around.
Oh, wow. So you said they found vertebrae, so that's part of the backbone. Were any teeth found, or was it just part of the backbone that was found?
Yeah, that's a great question. There actually weren't any teeth found associated with it. All we had were 3 vertebrae from our individual that were all about the same size, so they probably came from right about the same part of the body and from the same individual shark. So one shark, pretty large. The unfortunate thing with that, we didn't find teeth, because if we would have found teeth, we would have been able to identify which species it belongs to, because that's how we identify fossil sharks, is based on their teeth, not based on their vertebrae. So having the vertebrae, we're kind of at a loss at what species it belongs to exactly, but we sort of figured it out a little bit, or at least have a hypothesis to which species it belongs to, because, as I said, we found that we know about that other vertebra from Kansas. So we have this one from Texas, we have this one from Kansas, and since they were living at about the same time, they were contemporaneous, about 100 million years ago, we can look at the shark fauna that are known from teeth from both of those sites, and it turns out there's only really 2 that belong to that family of shark, and they're Cretalamna and Leptostyrax. Cretalamna tend to be a lot smaller, and we actually have teeth associated with vertebrae from that species from other deposits, and they look nothing like the 3 that we have and the one from Kansas. So we're hypothesizing that this species is Leptostyrax macrorhiza, which have sort of thin sand tiger-like teeth. And before this hypothesis, no one actually knew that they grew to this size. We always thought they were slightly smaller sharks, even though their teeth tend to be the largest large shark teeth found in the area, or at the time, in North America. But we didn't know quite that they got to this size based on their teeth alone.
Wow, so this is a really big finding about how big these how big these sharks actually get. I was just wondering, how did you calculate the size of the shark based on just these small pieces of bone? I had a look at the pictures. Then there's only like 3 small vertebrae, so just wondering how you calculated that.
Well, I mean, small, they're about that big.
Oh, wow.
Large in regards to vertebrae. The way we calculate it is actually by using algorithms that have been developed for other shark species. So we're not the first ones to do this. There have been many fossil shark papers that have attempted to actually reconstruct total length based on a single vertebra. So we used a calculation based on the modern great white shark, and one that was based on a Cretaceous shark called Cretaceous that tends to look a lot like a great white shark. So they're both kind of the same body plan. And for both of the estimates that we got, basically, the way that these other researchers came up with this algorithm is they basically looked at the largest vertebra in the body of a skeleton of one of these, and then extrapolated out to get the total body length. So essentially, what we're doing is we're hypothesizing that this animal would have had a similar body plan to one of these other sharks. Now that's problematic, because we're assuming that our shark, Leptostyrax, or what we think it is, would it look exactly the same or have the same proportions as a great white shark or this other one, Cretaceous. And in fact, if it is Leptostyrax, that species belongs to a more basal lineage, which probably had a very different body shape, possibly even a longer body. So this might actually be a huge underestimate of total body length. Further, we're assuming that the vertebrae that we have are the largest that would have been in the body of that shark. That's kind of a big assumption because we only have 3, and how many vertebrae do sharks have? A lot, right? So the fact that we're making that assumption totally means that our estimates are the most conservative minimum estimates total. So at minimum, this animal is as large or even larger than the largest great white shark ever found. But in likelihood, it is quite a bit bigger.
Wow. I was reading about how you found the fossils. Are there any plans to go back and look for any more pieces? Or
yeah, I mean, they were found totally by accident. That's something that, as much as my wife doesn't like me bringing up in every interview, so we were all going down to Texas as part of a field trip that was performed through the Paleontology Club at my undergrad university at the University of Wisconsin-Milwaukee. It was actually a club we started with a bunch of friends to basically go around the country and collect fossils just so we can learn about them, because there aren't a lot in the Midwest of the United States, at least cool ones like giant sharks. We weren't looking for sharks. You know, we were just going to places where we knew there would be fossils. And my wife ended up tripping over a boulder and looking behind her and seeing one of the vertebrae sticking out of the ground, which, you know, it's total accident, but that kind of led us down this path that ended up being a publication, which one that seems people are very excited about. So the original plan wasn't really to go back to any of these sites, but the more and more we're talking about this, the more we're thinking about it, we really don't see a reason why we shouldn't. The good thing is that the Duck Creek Formation, where these vertebrae were found, are not limited to right outside of Fort Worth, Texas. It's a formation that is distributed in northwest Texas all the way up to southern Oklahoma. So we have a lot of land to look through. So the plan is probably to start planning for next year to actually go look for teeth and associated vertebrae, so we can kind of solve this mystery on whether this animal is actually Leptostyrax or maybe another species of unknown giant shark that we never knew before.
That's brilliant. Are you quite hopeful for finding the teeth? I don't know, do sharks, they lose them quite regularly, so are the chances of finding more teeth higher because of that, or?
Absolutely, yeah. Modern sharks, they lose their teeth regularly. They're constantly shedding them. They have a lot of teeth, though. It's actually quite common to find shark's teeth in the fossil record. They're also made of hard enamel, so they tend to preserve quite readily. The vertebrae are actually quite rare because they're made of cartilage, and they tend not to calcify as heavily as vertebrate bone. So in the fossil record, finding a shark vertebrae is actually far more rare than finding the teeth. So the fact that we got the vertebrae, you know, it's kind of amazing considering that we didn't find any teeth. But teeth don't give you an accurate representation of body size, as you know, we know. So having the vertebrae tells us a lot more about the biology of this animal than having the teeth alone. So it's a great find.
That's great. So are you going to continue this research? Is this part of your PhD project or your current research? Or do you want to talk a bit about that?
No, actually, it's not at all. I'm not. I don't claim to be a shark expert. I am a paleontologist here. I'm a PhD student in my starting my 3rd year here at the University of Oklahoma. But I am actually my interest is in dinosaur growth and how other dinosaurs grew up and the ecology of dinosaurs. Specifically, I like looking at or I'm going to be looking at their diet changes as they grow through life, and mostly in the predatory theropod dinosaurs. So this was kind of a side project. It was sort of we found this fossil and nobody seems to want to work on it, but everyone's telling me that I should publish it. So I took them for their word and kind of went with it. And it seemed to work out. People seem pretty happy with it. So.
That's brilliant. Yeah, thank you very much for talking to us. We're going to put the link to the paper below so everyone can read it. As we said before, it's open access. We'll also put a link to your Twitter, if you have Twitter.
I actually do not. So.
We will not put a link to your Twitter then. Okay, thanks again for talking to us.
Oh, it was my pleasure.